Uncertainty. How much error is allowed in a measurement? So by the end of the lecture today, I hope that we establish a method for communicating the precision of a measuring instrument while making a scientific measurement, so within the scientific measurement itself. So let's start by defining uncertainty. We have this plus minus symbol. This basically tells people that we're talking about an uncertainty, and it represents what degree of quote-unquote estimation the scientist conducted when making a measurement. It's kind of a way of communicating how precise your measuring device is. There's a formula. Uncertainty equals, and this is in quote, the smallest increment of the analog device, and that whole quantity divided by 2. So let's see how this works in practice. Now I have a meter stick here, and I have a line drawn next to the meter stick, and you know what, it might be difficult to see, so I blew it up just a little bit. So when I try to establish the length of this line, basically this becomes a question of how many meters and how many portions of a meter this line occupies. The space before the decimal is the ones place, and basically it asks how many whole meters. And I hope that you recognize that this line is not even 1 whole meter. So what number are we going to use to represent the whole meters place? A 0. The next place is the tenths of a meter place, and that is represented by this, if we were to divide the meter stick into 10 parts, that would be 1/10 of a meter. And I hope that you recognize that we don't even have a tenth of a meter, so a 0 is going to be used to represent that number. Well, what about this next place? This is hundredths, and that is hundredths of a meter, which is also known as a centimeter. And that is the distance from here to here. Now, at this point, we can actually start measuring numbers. In other words, our line is longer than 1, our line is longer than 2, our line is longer than 3, but it hasn't made it to 4 yet. So I'm going to drop a 3 into this measurement. At this point, I'm going to move down into the blown up section a little bit, and I'm going to look. Now, there's more tick marks, but they're not necessarily numbered, but I could apply numbers. The reason they don't is it gets really cramped in there, but look at 1, 2, 3, 4, 5, 6, 7, 8, 9. And so now if I look at the end of my line, I see that it occurs between the 5 and the 6th. And so this goes in my thousandths place. Thousandths of a meter are also known as a millimeter. And at this point, I'm going to put a 5 here. Now, you will notice that the last the end of the line isn't quite on the 5 and it isn't quite on the 6. And me as the scientist, I get to estimate this last digit. And because it's, you know what, a little bit closer to the 6 than the 5, I'm going to estimate this 8. Now, to be honest, any scientist can estimate any number that they want, and so a level of uncertainty is involved in this measurement. So I figured out that I have a measurement of 0.0358. At this point, I need to establish what the smallest increment was. When we're trying to find increment, though, we want to know what is the smallest value from here to there, the smallest value between those 2 points. If I look, it's millimeters, and I write it 0.001 meters. And since we're using a meter stick, the millimeter is the smallest distance between the two tick marks. So that's 0.001 meter. I'm going to divide that by 2. And when I do, I get an uncertainty of plus or minus 0.0005 meters. Well, what does this look like when I actually write this number in scientific measurement? So first, I take this value, that is my measurement, that is how long the line is, but then I add the uncertainty to it. So I write 0.0358 plus or minus, this is the uncertainty part, 0.0005, and then the units, meters. Okay, but what does that mean? So basically the plus minus says that we can form a box around this measurement and everybody in the world should agree with these measurements. And so if I added 0.0005, the largest value that would be acceptable is 0.0365 meters. But then if I subtracted that my uncertainty, I'd see that my smallest value is 0.0353 meters. And therefore, I get this acceptable range running from 0.0363 all the way down to 0.0353 meters. Those are all acceptable values according to the scientific way of measuring, and you have what kind of an uncertainty box. So, if we apply the same idea again, what is the uncertainty of this clock? Well, I hope that you're trying to spend some time to figure out what the smallest increment of the clock is. To be honest, do we care what the hands are doing? No, we're just simply looking at the increments. From here to here is the unit 1 minute. Now before you go, well, it's 60 seconds, Faye. You know what, you're right, but in order to do seconds, we'd have to divide there to there up into 60 little parts, and we don't do that. So the smallest increment is 1 minute. In order to calculate uncertainty, I take the smallest increment, 1 minute, and divide it by 2. And I use this plus or minus to represent that it's an uncertainty, and when I do the math, I get 0.5 minutes. What about this clock, though? Can you figure out the smallest increment of this clock? This clock's a little different because there's no tick marks between this large hash mark and the next one, so the smallest increment on this device is 1 hour. So the smallest increment is 1 hour, and so the uncertainty is 1 hour divided by 2. So therefore, to indicate that this is an uncertainty, I'm going to plus or minus 0.5 hours. Okay, let's try another one. This one is a little bit tougher. You think you can figure out what the smallest increment of this beaker is? Well, I think you notice that, look, this line is labeled with 250, and this line is labeled with 300, but then there's a line right here that isn't labeled. But I can interpret that that's 275 milliliters. So what is the smallest increment from here to there? If you're uncertain, could I take 300 milliliters and subtract 275 to give me a grand total of 25 milliliters? That is the smallest increment on my measuring device. If I want to find the uncertainty, that is 25 milliliters divided by 2. And when I do the math, I use a plus or minus to indicate that this is a uncertainty 12.5 milliliters. Well, what is the uncertainty of this tape measure? How is this different than the other kinds of uncertainty problems we've been doing? Do you see that it's in fraction format? So that is 1/8. And actually there's a line right there, and that refers to 1/16. Yuck! Trying to do uncertainty in the imperial system where you use fractions of an inch or a foot gets really, really messy. Which is why scientists like metric systems.